Okay, so we learned three things: atomic size, then the ionization potential, and electron affinity. The next thing what we are having is electronegativity, that is electronegativity. Now, electronegativity is a tendency of an atom to attract electrons to itself. See, any particular atom will have the property to attract the electrons towards itself. Moreover, it will be much more prominent when it is a covalent bond, that means the sharing of electrons is taking place. At that time, the shared part of the electrons, when they are attracted towards that atom, then the electronegativity is much more important. But otherwise, generally speaking, electronegativity is the tendency of an atom to attract electrons towards itself when combined in a compound. So when the two atoms are there, this is one atom, this is another atom, अगर यहाँ से एक atom इधर जाता है और ये attract करता है उसको, तो वो attraction to that electron is the electronegativity of this thing. Or if they are sharing electrons over here, then the electrons are being pulled over this side or they are pulled over this side because of the difference in the electronegativity between them. So that's why we say electronegativity is nothing but the tendency of an atom to attract the electrons towards itself when combined in a compound. So you can see now, it's very easy to understand in a simple manner कि अगर कोई metal हुआ, metal अपने electrons को देता है. It is going to release its electrons. It is going to give away its electron. That's why ionization potential is low. So when the ionization potential is low, जो अपना खुद का इलेक्ट्रॉन पकड़ के नहीं रख सकता है, तो ऑटोमेटिकली शेयर्ड पेयर में उसको अट्रैक्ट करना तो बहुत डिफरेंट हो जाएगा, राइट? वन सेकंड. So we can see over here that if a metal is there, metal will always have electronegativity as very low. Okay, so you can see that here it will be low, whereas over here as I go further it will be very high, because a non-metal will have a tendency to attract the electrons towards itself, and that is the reason they accept electrons. So because they are accepting electrons, they are the electron acceptors and these are the donors. That's why the donors will always have a low electronegativity, whereas the acceptors, that are the non-metals, will always have a higher electronegativity. Accordingly, what we see is that when I go from left to right in a periodic table, the electron negativity is always going to increase. So as I go from left to right, it is going to increase. Again, the reason is the same as that of ionization potential and electron affinity. What is the reason? Okay, when I go from left to right, over here the nuclear charge is less, the size of the atom is big, so automatically to hold the electron towards itself is a lesser capacity, whereas over here the electrons are shrink, they are smaller, and the nuclear charge is stronger, hence it will attract the electrons much more towards itself than these ones. So as I go from left to right, the electron affinity, electronegativity of this particular elements are going to keep on increasing. So that's why we see that from left to right, when we go, the electronegativity keeps on increasing. Hence, what will be the result when it is going down the group? So when it is going down the group, again the same fundamental laws as we used in the ionization potential and electron affinity. Down the group, what is going to happen? As I go down, the size keeps on increasing. Mode of the nuclear charge increases, but the size is superimposing the nuclear charge. Hence, it becomes much difficult for it to hold the electron towards itself, so it is going to decrease. So as I go from top to bottom in a group, the electronegativity is going to keep on decreasing. So where we see the tendency or the trend of the characteristics of periodicity in electronegativity will be that when I go from left to right in a period, then it is going to increase, whereas when I go right, top to bottom in a group, it is going to keep on decreasing. This property or increasing decreasing property is similar for all the three. Ionization potential also the same way, increasing decreasing. This one electron affinity also same way, increasing decreasing, and electronegativity also same way, increasing decreasing. In this particular thing there is one small, we can say, exception. Let's see the exception over here. If I see the group 17, the group 17 has got over here fluorine, then chlorine, then bromine and iodine. So if I see the electronegativity of these things, it will be seen that electronegativity of, sorry, just a minute. Okay, so over here it is going to be this way only, it is going to be decreasing. I missed out one point over here in the exception. There is of the electron affinity. Okay, I'll come to the last about this part. Okay, I'll just come to that in the last. We'll take up all the exceptions in the last. So right now we'll just consider it this way, that when I am going from left to right, it is increasing and decreasing down the group. Okay, so that is about the electronegativity. Now comes the last two factors, and that is, the first one is metallic character and the second one will be non-metallic character. So I'll just erase this part. Now first one is metallic characters. What is the metallic character? What is the characteristics of a metal? The character of metal basically is that they have the capacity to donate electrons or give away electrons. So electrons are, the property of losing the electrons is that of the metals. We know very well, lose कौन करेगा? वो lose करेगा जिसका atomic size बड़ा होगा, ionization potential कम होगा, electron affinity कम होगा, electronegativity कम होगा. That means if you see the trends, you come to know that this area which has got the higher size of atom, this has got, so it is like atomic radius is greater, whereas ionization potential is smaller. This has got electron affinity which is smaller and electronegativity also smaller. So these areas have got this property which is ideal for losing electron. Okay, one can easily lose electron. So loss of electron is going to take place in this particular case. So because of this, they are called as metals. So metals are towards the left, and as they go from here to here, what is going to happen? So you can see, as I go here, my radius is going to decrease, IP is going to increase, this increase, this increase. So automatically metallic characters कम हो गया, और आगे गया और कम हुआ, और आगे गया और कम हुआ. ऐसे करते करते when we go up to this point, you will find that the metallic characteristics over here will keep on decreasing. So the metallic characters keeps on decreasing as I go from left to right, because as I go from left to right, the capacity to lose electrons keeps on decreasing. Similarly, when I go from top to bottom, it is seen that as I go down, what is going to happen? The radius is going to keep on increasing. Ionization potential is going to keep on decreasing. ये भी और decrease होगा, ये और decrease होगा. That means this point over here, the lowest one, so this is going to be highest metallic. So this will, I'll be increasing order. So increasing order will be there when it is going to be like this. So increasing order of the metallic characteristics down the group and decreasing order across the period. If this is the condition, automatically non-metallic will be exactly ulta of this. So when I talk about non-metallic, so non-metals, What will happen in the case of non-metals? We know very well non-metals are going to accept electrons. यानी कि यहाँ पे कोई accept कर ही नहीं सकता है, यानी यहाँ पे है. So maximum non-metal is over here, and it is slightly less over here, slightly less here, and absolutely nil over here. So this over here, it is decreasing in this order, means it is increasing. So if it is see this way, it is red one is increasing. So increase in the non-metallic characters as I go from left to right. Obviously, when I go down the group, it will decrease. Why it will decrease? In the same reason as this one. So as I go down, what will happen? Its capacity to accept electrons decreases because the size of the atom increases. Automatically you see over here the nuclear charge भले increase हुआ पर size increase होने के कारण nuclear charge compensate नहीं कर सकता है. Hence non-metallic characters, as I go down, it keeps on decreasing. So across the period it increases, down the group it decreases. This was the trends for the 6 different physical and chemical properties of the elements in a periodic table. So we studied the 6th one. The first one, atomic radius. Second one was ionization potential. Third one was electron affinity. Fourth, electronegativity. Fifth, metallic character. And sixth as non-metallic character. So if you see this thing in a like if you want to make this into a form of a chart, or we say to combine form में अगर उसको याद करना है, तो we can always make it this way. I can always use it this way, that let's take one by one. So we'll not take it this way. So we'll say over here atomic radius. This over here decrease, and this over here increase. Okay, that is the first thing. The next one, let's take all these characteristics. Okay, we'll do one by one only. Okay, this the next one is ionization potential, IP. As I grow from year to year, it increases. When I go down, it decreases. The next one is, or I'll take all the ulta one as blue, so it is electron affinity. The electron affinity, again as I go here, it increases, and if I go down, it is going to decrease. Okay. The next one is electronegativity. Electronegativity, as I go this way, it is going to increase. When I go down, it is going to decrease. Okay. Next comes the metallic character. So metal over here it decreases, whereas down over here it increases. And finally is the non-metal. So non-metal, this is going to increase, whereas this is going to decrease. So this was about the complete, you can say the properties, periodic properties of a periodic table. Now I was just telling you about one particular exception we were talking about, and that exception is in the case of electron negativity. Now in case of electron negativity, I'll just put it with something else as electron affinity of Cl is higher than F. See, normally what happens is, we know that it will be FCl-Bri. So according to this particular thing, this electron affinity is going to decrease down the thing. So this should be like this, that this should be the highest, then should be Cl. But here it is different, that Cl ऊपर है और F नीचे है, only in the case of electron affinity. So the electron affinity के अंदर it is a condition, or we can just say that the element with the highest electron affinity is going to be chlorine. So highest electron affinity is of chlorine. Okay, this is the important part. This is a kind of we can say an exception in this particular table. So this was about the chapter. As such, I think we have covered everything over here. Now, some important things we can just note it down. I will just speak out that those important things which are there as an exception गिन लो या something important है. So first is the element helium has the highest ionization potential while cesium has the lowest. So this is something very important, that element cesium has the lowest and helium. So over here we can write over here that in ionization potential we have got ionization potential में सबसे पहले highest is going to be helium and lowest is cesium. Okay, helium is the highest and cesium is the lowest. Francium being radioactive, see actually cesium and all comes over here, so cesium and francium are here, but so francium should have been the maximum over the lowest over here, but francium being radioactive, that's why it behaves in a different manner. So we say that the lowest IP is of cesium, highest IP, lowest IP is of cesium and the highest IP is of helium, which is actually a inert gas. Similarly, neon, if you talk about the electron affinity of neon, that is the inert gas, you will find that it is 0, because electron affinity, what is electron affinity? It is the tendency to accept electron. Now, inert gases do not accept electron, that's why all inert gases 18 का जितने भी है, we all will have an electron affinity as 0. Okay, so that of neon will be automatically 0, and electron affinity में highest will be of this group. So automatically fluorine will be highest in case of electron affinity. Electron affinity में यही था. So electron affinity is chlorine. Chlorine has got the highest electron affinity, and next thing is, okay, so this is about chlorine and electronegativity wise, again the same thing. Fluorine has the most electronegative element, so fluorine is the most in electron negativity. Electronegativity highest is in fluorine. Noble gases have complete order, so they do not attract the electrons to itself, hence again the electron negativity of these ones will be 0. So it's quite easily given in the textbook also, but you need to remember these things because they are the important questions which are normally asked in boards or in any particular kind of examination. So that's why we need to know that which is the highest, which is the lowest in all these trends. So all these trends may, most of the thing you can easily identify because you know this trend. So you just need to remember the position of the elements in this periodic table. You very well know the first 20 elements. So hi, hello, listen to BBC News, that part you should know. So automatically if you know the first 20 elements, that solves most of the problems. After that you will need to learn the sequence of the group 1 element and the group 17 element. Group 1 and group 17, they do ask you to write them in the ascending and descending orders. So that's why you should know the group 1 element over here. In group 1 element, hydrogen may not be considered. So hydrogen is not considered. We'll always take as a lithium, sodium, potassium, cesium and francium. So that will be the way we are going to take the group 1. And of course in the group 17 will be fluorine, chlorine, bromine, iodine. So that are the halogens which are there in this particular part. So that's the end of the first chapter of chemistry, that is periodic table. Next time when I take chemistry, I'll be taking chemical bonding. So that's it.